On CP3-5, we're going to apply the formula for circumference of a circle to word problems in real-world situations, and we'll practice using dimensional analysis to solve problems and convert units. All right, so we are trying to switch 100 meters in 9.63 seconds to miles per hour. So I'm always going to start with my given rate, so 100 meters in 9.63 seconds. And I always like to change my numerator first, but it doesn't actually matter. I'm going to multiply this by 1, but I'm going to be sneaky about it. Okay. I'm going to multiply it by 1, but it's going to be wearing like a funny disguise. So to cancel out meters, I need to have meters in my denominator, because now these divide out. But I need to make sure that this number equals 1, meaning my numerator and my denominator are the same thing. And I'm told down here that 1 meter is about 3.28 feet. So if I put 1 meter here and 3.28 feet here, this equals 1, because 3.28 feet and 1 meter are the same. So this is just like multiplying by 1, but I'll be left with units in feet rather than in meters. Then I'm going to multiply to get my feet into miles. Feet is already in my numerator, so I need to have feet in my denominator so that these cancel out. Again, down below, if I did not know it, 5,280 feet in 1 mile. And now, the only unit I have in my numerator is miles, which is what I want. My next step is I need to do the same thing with my denominator. So I'm going to multiply by something that equals 1. So my numerator and denominator need to equal the same thing. But I'm trying to cancel out seconds. And I'm going to switch seconds into minutes and then minutes into hours. So I know that there are 60 seconds in 1 minute. And I know there are 60 minutes in 1 hour. And now the only units I have that have not been canceled out by having 1 in my numerator and 1 in my denominator is miles per hour. So if I multiply straight across here, I'll get my answer in miles per hours. And then I can simplify that fraction. So in my numerator, I have 100 times 3.28 times 1 times 60 times 60. So I get 1,180,800 miles. In my denominator, I have 9.63 times 1 times 5,280 times 1 times 1. I need to reduce that, so I'm going to divide it so I get miles per 1 hour. So I have 1,180, or 1,180,000, my goodness, 800 miles, divided by 50,846.4 hours, gives me 23.2 miles per 1 hour. A little bit slower. Clem can walk 6 inches in 15 seconds. I have no idea if that's true. I didn't actually time her. Seems about right. I'm trying to get, again, to miles per hour. I'm going to switch my inches into feet first. 1 foot is 12 inches. So my inches have canceled out. 5,280 feet is 1 mile. So I'm in miles per second now. Do the same thing with your seconds. 60 seconds is 1 minute. 60 minutes is 1 hour. And now my only units I have are mile per hour. Hopefully this is all looking really, really familiar, that you did this in 6th and 7th grade. If not, this is great practice. We're learning. So now I'm going to multiply straight across my numerator and straight across my denominator. So I have 6 times 1 times 1 times 60 times 60. And I get 21,600 miles per. For hours, I have 15 times 12 times 5,280 times 1 times 1. I'm going to divide these so that I get it per 1 hour. And she is going 0.023 miles per hour. So a little bit slower, but that's okay. We still like her. All right, we're going to switch gears a little bit here. You will need to be able to do this and change your units on, I believe, just one of the checkpoint problems and potentially on your test, so be mindful of that. Our circumference is just the distance around the circle. And recall, we used the formula this year, 2 pi r or pi d, where r is your radius or d is your diameter. And we're going to do some practice with this. So the wheel on Susie Cream Cheese's unicycle has a diameter of 27 inches. We want to know how far will it travel in 100 revolutions, and I'm being told to round. So while I've always told you do not touch the pi button, don't do it. If you're asked to round, you can go ahead and touch the pi button. The length around the wheel is going to be the circumference. So the circumference equals 27 pi. And while it does say round, and some of you want to round right now, we're going to round till at the very, very end, because otherwise we round too early. And if you round up earlier, you're off every single time you use that number then. So every time you multiply it or add something, you're off more and more and more, and bad things happen. So we're going to keep it as 27 pi till the very end. Then you get to round. She's going to turn that wheel 100 times over. So the distance will equal 100 times the length of each one that it turns over, 27 pi. So if I throw that into my calculator, and for some reason it's not showing the pi in this, so don't stress about that if yours is doing the same thing. And I get 8,482 inches. But I was asked to round to the nearest whole foot. So I'm going to think 1 foot is 12 inches. My inches are canceling out, so that tells me, hey, divide by that 12. So I really have 707 feet. Same unicycle. She's riding it 2 miles to school each day, and we want to know how many times is it going to turn. So my distance will equal the number of times it turns, so the revolutions, times the circumference. So I know I'm going 2 miles. I'm going to switch miles into inches because I'd rather deal with a really big number than deal with a teeny tiny decimal. Okay. So over here I'm going to say, okay, 2 miles I'm going to first switch miles to feet. I have 5,280 feet in 1 mile. Then I'll switch feet to inches. 1 foot is 12 inches. So I have 2 times 5,280 times 12. So that's how far she has to travel in inches every day to school. We don't know our revolution, so I'm going to keep r in for that. Our circumference is still 27 pi. To get r by itself, I need to divide by 27 pi. And again, because I'm being told about, I can hit the pi button and give an estimate. So my number of revolutions is about 1,494. On this next one, Billy Bagel's driving a remote control car in a circle. The radius is 5 meters. Okay? If the radius is 5 meters, that means the circumference is 5 times 2 times pi, or 10 pi. It's going that distance every 10 seconds. We want the speed of the car in meters per second. So right now it's going 10 pi meters in 10 seconds, which means in 1 second, well, I can easily divide that by 10, and I get pi meters per second. I would probably in the real world say it's going 3.14 meters per second, but you could say pi meters and be even more exact. All right, Patty Peanut Butter opened up a pizza place. That's a lot of P's. She's selling a 7-inch pizza for $12. She's selling an 8.5-inch for $14.50 and a 10-inch for $16. Okay, that's the radius of the pizza. We want to know which size has the most crust per dollar. So we're going to figure out the price for 1 inch of crust each, or rather how much crust you're getting for each dollar, and then we'll compare. So on this pizza, 7 is your radius, so you have 14 pi inches for $12, which means my unit price is 14 pi divided by 12. We're going to call it 3.67 inches per $1. On that medium one, 8.5 is my radius, which means 17 pi is my circumference. I'm getting 17 pi inches of crust for $14.50, which means for every $1, I'm getting 17 pi divided by $14.50, which is 3.68 inches for every $1. And lastly, for that large pizza, you're getting 20 pi inches for every $16, because our radius is 10, so our diameter is 20, which means for $1, you're getting 20 pi divided by 16, 3.93 inches for each $1. So for that $1, I can get 3.67 inches, 3.68 inches, or 3.93 inches. If the only thing that matters to me is how much crust I get, my best buy is that large pizza, because I get almost 4 inches of crust for every single dollar that I spend.